I must say that I'm very excited to be here, to be invited, to get the recognition, and to be able to give a lecture. It's not my first lecture and not my first recognition, yet it is moving. And thank you for inviting me, the university, and the bridges. Yeah. What I try to say is that mankind needs to be healthy and have relatively good life in order to talk about future and sustainability. It's not only the geographical and the ecological factors, it's also us, people. Then I think that health is the most important factor from this point of view. We really want to give our children and grandchildren a healthy world, or a world that they can approach diseases in a successful way. So let's talk about something else. What's common to all these guys? So we are not going to make a quiz here. They are all giants. Some are composers and some are writers. They are all giants in their field. They all died very young. I'm sorry, you are laughing, but it's very sad. Can you imagine if Mozart would live just 20 years more? He died 36. How many more symphonies we would have? Okay, so they're all giants, they all died young, they all died before or at the middle of last century, and what you cannot see in the slide is that they all died from infectious diseases. Infectious diseases are currently much less death-causing. We talk about pneumonia or problem in the stomach and things like this that we can treat today, but not before the middle of last century, when Orwell died. This is when antibiotics became useful medically. And because of the fundamental role played by the ribosomes, many antibiotics inhibit it. It means infectious diseases are caused by bacteria. If we want to get rid of the bacteria, we can, not we, but the ribosomes can be stopped. No ribosomes, no proteins, no life for the bacteria. Not for the patient, but for the bacteria. So ribosome is targeted, is inhibited by many antibiotics, almost half of the all useful antibiotics. Natural antibiotics are the weapons that one type of microorganism is producing to interfere with the life, to fight against other types of microorganisms. So as I said earlier, over 40% of the clinically useful antibiotics target protein biosynthesis. Now, antibiotics are very small. Their size is between 500 to 1,000. And ribosomes, even in bacteria, are 2.5 million. So how come these little tiny antibiotics paralyze the giant ribosome? So the idea is, if ribosome is a factory, it is an assembly line. In an assembly line, any step that you stop the assembly, so stop them. So this is what the antibiotics do. You see here the skeleton of the large subunit and of the small subunit, and on it there are balls. Each ball represents a family of antibiotics. So may I tell you something about myself? When I started to determine the structure of the ribosome, everybody laughed at me. Not everybody. 99% of the scientists laughed at me, and I was not sure that I will get there. But even in my best dreams, I didn't think that I will be able to see this little thing on the ribosome. This was above my imagination.
Whereas she has further distinguished herself as the first Israeli woman to win the Nobel Prize, the first woman from the Middle East to win a Nobel Prize in Science, and the first woman in 45 years to win the Nobel Prize for Chemistry. Whereas, in recognition of her pioneering studies on protein biosynthesis by ribosomal crystallography, thereby introducing a novel technique called cryobiocrystallography that revolutionized the field of structural biology and has given it wide-ranging applications, particularly in the development and design of new antibiotics. The Board of Trustees and the academic community of De La Salle University are pleased to confer upon Ada E. Yonath, 2009 Nobel Laureate for Chemistry, a multi-awarded research scientist and scholar, the degree Doctor of Science, honoris causa.
Congratulations, Professor Ada Yonath, Doctor of Science, honoris causa.